Basic trigonometric equations. In this video, we will attempt to solve trigonometric equations. There are a couple of different types of equations. If you look at the three equations here, the first equation is actually true for all values of theta. And this is what we call an identity, right? Because it doesn't matter what value of theta we plug in here, this is always true. The other two are truly equations that need a solution. 2 sine of theta minus 1 equals 0 is only true for certain values of theta, but not all values of theta. The same is true for the second equation here. So some equations need solving. Other equations that are true all the time we call identities. So in this video, we're going to focus on equations that need solving. So for example, let's solve the equation sine of theta is equal to 1/2. So what we're asking for here are, what are the values of theta for which sine of theta is equal to 1/2? Now you might recall from the unit circle that at theta equals pi over 6, the y value of this point is 1/2. And also at theta equals 5 pi over 6, the y value of the point here is 1/2. So we know that sine of pi over 6 is 1/2, and we know the sine of 5 pi over 6 is 1/2. So we for sure have two solutions. But if you go to the graph of the sine function, you'll see sine of pi over 6 equals 1/2 is represented by this point here. Sine of 5 pi over 6 equals 1/2 is represented by this point here. But you'll notice that if you keep going on this horizontal line at a level of 1/2, you will find many other values of theta for which sine of theta is also equal to 1/2. And we have some of these values listed here. Now, this is, of course, because the sine function is a periodic function. So the horizontal distance between this value of x and this value of x is 2 pi, because that is the period of the sine function. And the distance between this value of x and this value of x is also 2 pi. So we can capture all of the solutions to this equation by simply realizing that if we have the fundamental solution, which in this case is pi over 6, we can add any multiple of 2 pi, and that's going to give us another solution. So the way I can represent all the solutions here is pi over 6 plus 2 pi times k, where k is equal to any integer. All right, so for example, if k equals 1, we're adding 1 multiple of 2 pi. If k equals 2, we're adding 2 multiples of 2 pi. If k equals -1, we're subtracting a multiple of 2 pi. And that will give us the solutions in the other direction. So the two solutions are x equals pi over 6 plus 2 pi times k, or 5 pi over 6 plus 2 pi times k. And in both of these cases, k is equal to an integer. Now, just a little bit of a detail here. Sometimes people don't write it exactly in this format. So, I could also say x equals pi over 6 plus 2k pi, right? So sometimes the pi and the k are switched around. That really doesn't matter too much. So I can do the answer like this. And then other times, instead of using k, they'll use n. So for example, I could say x equals pi over 6 plus 2n pi, or 5 pi over 6 plus 2n pi. So these are details. These are not, that important. But I just want you to understand that if you see an n instead of a k, or if the k and the pi are switched around, that is not a big deal. So the important thing here with these trig equations is to recognize the fact that when you're solving trig equations, you are often going to get infinitely many solutions. Infinitely many solutions. So in our second example, this is very much the same thing. We have the cosine of theta equals negative radical 2 over 2. Now we know that cosine is negative in the second and third quadrants. So according to the unit circle, cosine is going to be negative radical 2 over 2 at the angle 5 pi over 4. and it's also going to be, at the angle 3 pi over 4, and then it's also going to be negative radical 2 over 2 at the angle 5 pi over 4. So we have two sort of fundamental solutions, and of course you can look at those on the graph of cosine. These are those two solutions, but then of course there are infinitely more solutions as you move across this graph. So the fundamental solutions are going to be theta equals 3 pi over 4 plus 2k pi, or theta equals 5 pi over 4 plus 2k pi. And once again, k is equal to an integer. So this part of the solution is not too hard to get, but it's the beginning. It's the fundamental solutions. It's the 3 pi over 4 and the 5 pi over 4 that you really need to focus on, because that's the beginning of all the solutions. So these are the infinite solutions that we have, but they want you to also list 8 specific solutions. So if they want you to list specific solutions, what that means is you need to plug in integer values for k. So for example, if I let k equal 0 in both of these formulas, we're going to get 3 pi over 4 and 5 pi over 4. If we let k equal 1, which we're certainly allowed to do, this first solution here is going to be 3 pi over 4 plus 2 pi, and the second solution will be 5 pi over 4 plus 2 pi. Now, if you get a common denominator here, you're going to end up with 11 pi over 4 for this one and 13 pi over 4 for this one. So that gives us 2 more solutions. And then if you let k equal 2, right, if I plug in 2 here, I'm going to be adding 4 pi to both of these. And then we're going to get 2 more solutions. And those next 2 solutions are going to be 19 pi over 4 and 23 pi over 4. That's 6 total solutions. And so lastly, if I let k equal 3, we will get 27 pi over 4 and 31 pi over 4. And so these are 8 specific solutions. Now in this next problem, we have cosine of theta is equal to 0.65. 0.65 is not a special value that shows up on the unit circle. So to solve this thing here, we are definitely going to need to use a calculator. So what we need to do here is find the angle theta bar, the reference angle, for which this is true. So we know that cosine of the reference angle is 0.65. This means that theta bar is going to be the inverse cosine of 0.65. And if you plug this in on a calculator, you're going to get in radians approximately 0.86. Okay, so I'll just remind you here that this is radians. Now that's the solution in the first quadrant, right? We know one solution is in the first quadrant because cosine is positive in the first quadrant, but cosine is also positive in the fourth quadrant. Now this theta bar right here is the same. It is also 0.86. But as a solution to this equation, we need to express that angle theta like this. And so theta is going to be 2 pi minus 0.86. And if you do the math on this on a calculator, you're going to get 5.42. And that's where you see this other solution coming into play here. So that is this angle in radians. So our 2 solutions are going to be theta equals 0.86 plus 2k pi, or theta is equal to 5.42 plus 2k pi. And once again, k is equal to an integer. Next up, we have an equation involving tangent. We have tangent of theta is equal to 2. And once again, 2 is not a special value on the unit circle for tangent. So to solve this equation, we need to find the reference angle. So there is an angle theta bar, and tangent of theta bar equals 2. And so theta bar is going to be the inverse tangent of 2. And you can plug this in on a calculator. Now, of course, when you do this, you need to make sure your calculator is in radian mode. So inverse tangent of 2 is approximately 1.12. And you can see that they've given you that value there, but that just comes directly from your calculator. And so what are the solutions going to be? Well, again, we have tangent equals 2 right here, but then tangent is going to equal 2 again here, again here, again here, and here. And so what separates all these solutions is the period of the tangent graph, which of course we know is pi units. So if you want all the solutions, we're going to have 1.12 plus k times pi. And again, k is equal to an integer. Now, if you want to see that on the unit circle, we know that tangent is positive in the first quadrant. So there's an angle here where tangent of theta is equal to 2. But then tangent is also equal to 2 in the third quadrant, right? Because tangent is also positive in the third quadrant. And so this is your other theta. Now, notice that these angles here are 180 degrees apart, or pi radians apart. So you can capture all of your solutions by just taking the first angle here, which is the 1.12, and then just adding multiples of pi to it. So the next equation here, you have 2 sine of theta minus 1 equals 0. The first thing I need to do in this equation is get the trig function by itself. So if we add 1 to both sides, we have 2 sine of theta is equal to 1. And then if we divide by 2, we have sine of theta is equal to 1/2. Now, this problem is the same as the very first problem that we did. So we know that the solutions here are going to be pi over 6 plus 2k pi, and also 5 pi over 6 plus 2k pi. And again, k is equal to an integer. But this equation requires some initial steps before we can get to solving it. In the next example, we have tangent squared of theta minus 3 is equal to 0. So if we add 3 to both sides, that gives us tangent squared of theta is equal to 3. And then if we take the square root of both sides, we have tangent of theta is equal to plus or minus the square root of 3. So now we got to think about where is tangent positive radical 3 and where is tangent negative radical 3. Well, the positive radical 3 for tangent is going to happen in the first quadrant and the third quadrant. And the picture of the triangle would look something like this. It's going to be radical 3 over 1, or down here it'll be negative radical 3 over negative 1. And we should know that this angle here is 60 degrees in both cases. And 60 is pi over 3. So one set of solutions is going to be pi over 3 plus k pi, because again, these angles are 180 degrees apart. But tangent can also be negative radical 3, and that's going to happen in the second quadrant and in the fourth quadrant, and the triangles here look identical to these triangles. So once again, we're going to have a 60-degree angle here, which means that this angle will be 120 degrees, and 120 degrees is 2 pi over 3. And again, we're going to add k pi to that, because once I have this solution, if I add pi units to it, I get this solution. So we can capture all of the solutions by just stating these two. And then, of course, I am going to say, k is equal to an integer. Next, we have a quadratic equation in cosine of theta. So when you have a quadratic equation, you can attempt to factor it. So in this case, let's go ahead and try to factor the left-hand side. So 2 cosine squared of theta. I'm going to take a guess. That's going to be 2 cosine theta times cosine theta. And then positive 3 can only be 1 times 3 or 3 times 1. I think we want it to be 1 times 3, because 2 times 3 will give us 6. 1 times 1 will give us 1, and 6 plus 1 is 7. And then we just need minuses on both of these. Now we're going to set each one of these factors equal to 0 and solve for cosine. So if we do that here, we get these two equations. Notice that this equation has no solution. It's just kind of nice because we don't have to do anything else with it. And this is because cosine can never be a value larger than 1. But cosine definitely can be positive 1/2. And we know that that happens in the first quadrant and the fourth quadrant, and those two angles are pi over 3 and 5 pi over 3. So the solutions here are going to be pi over 3 plus 2k pi and 5 pi over 3 plus 2k pi. And again, k is an integer. And finally, here we have a trig equation that we're going to solve by factoring, but it's a different kind of factoring. Notice that this is not really a quadratic type of equation. We have a mixture of trig functions here. So what's nice about this equation is both terms have a cosine of theta. So I can actually factor out the cosine of theta, and that leaves us with 5 sine of theta plus 4, and then equals 0. And then we can set cosine of theta equal to 0, and 5 sine of theta plus 4 equals 0, which simplifies to sine of theta equals negative 4/5. And then we can just solve. So what are the solutions for cosine theta equals 0? Well, we should know that cosine is 0 at pi over 2, this angle, and also at 3 pi over 2. So we can actually capture all of those solutions by simply saying pi over 2 plus k pi. Okay, and the reason we can say k pi is because these two angles are pi units apart. And then where is sine equal to negative 4/5? Negative 4/5 is negative 0.8. There we go. To get this, you would say sine of the reference angle is 0.8, and then you would find the reference angle by taking the inverse sine of 0.8, and that would give you the value here, which is 0.93. And then your angle here in the third quadrant is going to be pi plus 0.93, and the angle in the fourth quadrant is going to be 2 pi minus 0.93. Now, they express it as a negative value. I actually don't like that. I'm going to express this as 2 pi minus 0.93. And we can approximate that. So 2 pi minus 0.93 is 5.35. And then the other one is pi plus 0.93. And we can also approximate that one, which is 4.07. So my other two solutions here are going to be theta equals 4.07 plus 2k pi, and theta equals 5.35 plus 2k pi. And this captures all the solutions. And that concludes this video lesson.